Hi, welcome to Chemistry Made Easy. If today is the first time you're watching this channel, I urge you to subscribe, like, share, and comment. Today we'll be looking at radioactivity. And radioactivity, we'll be treating this topic in parts. So today we will be looking at the first part under radioactivity. Under this topic, we'll first of all look at the definition of radioactivity. Then we'll look at radioactive and non-radioactive materials or nuclei. Then we'll look at the types of radioactivity. Then we'll look at differences between nuclear reactions and chemical reactions. So this is what we'll be looking at today in part 1 of radioactivity. Now let's start. Now when we talk about the word radioactivity, the word radio is from radiations. So it means that this particular nuclide involves radiations. And the word activity is a process. So what is radioactivity? So you can therefore define radioactivity as it is the disintegration of an unstable atomic nuclide into another nuclide accompanied by the emission of radiations and energy. So when an atomic nuclide disintegrates, mostly these are what? Unstable nuclei. Why are unstable nuclei disintegrating? They are disintegrating because they want to become stable. Okay, so that's the essence of radioactivity. These atomic nuclei want to become stable. Because they want to become stable, they undergo what we call a disintegration. Disintegration basically means that these nuclei will break down. And when they break down, they give us other nuclei. And then these nuclei are accompanied with some radiations and energy. Radioactivity cannot occur without radiations and energy being released. So when you are defining radioactivity or you are writing an equation to denote radioactivity, you must make sure that your product contains some radiations, and these radiations can either be alpha, beta, or gamma, and then together with what? Some energy. Okay, so basically that is radioactivity. So we mentioned the word nuclide. What is a nuclide? We say when we talk about nuclides, they are basically atoms with specific atomic number and mass numbers. Okay, so example, if I have carbon 612, it can be regarded or called a nuclide because carbon has a specific atomic number and a specific mass number. So we call them nuclides. Okay, the next thing we want to look at is a non-radioactive material or nuclide and a radioactive nuclide. What is a radioactive nuclide? So when we talk about radioactive nuclides, they are basically unstable nuclides that undergo disintegration. Okay, so nuclides that are unstable and then they will break down to give you other nuclides are called what? Radioactive nuclides. Okay, so example, I can have uranium, which is uranium 238 with 92. I can have carbon 14. These are all unstable nuclides. Therefore, we call them what? Radioactive nuclides. They undergo disintegration. Now, when a nuclide does not undergo disintegration, we call it what? A non-radioactive nuclide. So non-radiactive nuclei do not disintegrate because they are stable. Therefore, because they are stable, they will not undergo any disintegration. And examples are the first 20 elements. Okay, the first 20 elements basically are all stable nuclei. So I can have carbon, this time carbon 6 with a mass of 12. This is a stable nuclide. Okay, so we call these particular nuclides non-radiactive nuclides. Okay, now the next thing we want to look at is what if you don't know how to identify a radioactive nuclide from a non-radiactive nuclide? If you were presented a periodic table and you were asked which of these elements on the periodic table are radioactive, these ones are not, how would you do that? It is simple. We can use basically what we call the neutron-proton ratio. The neutron-proton ratios of elements or nuclides can be used to determine whether a particular element is radioactive or it is non-radioactive. So let's check. Now, the first thing we can do is we said we are trying to check if the element is radioactive or not. So we are using what we call the neutron proton ratio. In using the neutron proton ratio, if you have an element that is those that have the atomic number ranging from 1 to 20, and their neutron proton ratio lies between 1.0 or 1:1, we say that those particular nuclides are non-radioactive. So, for example, if you have any of the elements, for example, if I have carbon, I'll have a neutron number of 6, a proton number of 6. The neutron proton ratio would be 6/6, which will give me 1.0 or 1:1. So elements that falls within or have the atomic number ranging from 1 to 20, we say that those elements are non-radioactive. Now from 21 to 83, elements that have the atomic number from 21 to 83, if those elements have their neutron proton ratio to be either 1.2, we consider them non-radioactive. And if they have from 83 upwards, if they have their neutron proton ratio greater than 1.5, then we consider them radioactive. Okay, so mostly for this last part, element that ranges from 83 upwards, whether they even fall below 1.5, they are mostly considered as radioactive elements. Now, the next thing we want to look at is the types of radioactivity. Now, we said that there are two main types of radioactivity. We have natural radioactivity and artificial radioactivity. What is natural radioactivity? As the name implies, natural. So something that is natural means that it is not by the influence of man. We are saying that these radioactive elements by themselves will undergo a disintegration. When the radioactive element identifies that it is unstable, that element will disintegrate by itself. Okay, so when they undergo disintegration by themselves to give us other nuclides accompanied by the emission of radiations and energy, we consider that particular type of disintegration and natural radioactivity. So we can say that natural radioactivity is the spontaneous disintegration of an unstable atomic nuclide into other nuclei, accompanied by the emission of radiations and energy. Now, you can use an equation to back natural radioactivity. For example, if I have uranium 238, an atomic number of 92, this uranium can undergo a disintegration to give me thorium 234 and an alpha particle together with energy. This is a natural radioactivity. So what have it emitted? It has emitted an alpha particle. Parent nuclide, after it has undergone the disintegration, would be the one that will tell you the type of radiation that will be emitted. And these radiations emitted are accompanied by energy. So, and one thing you also have to note is that in natural radioactivity, you have a single parent nuclide. Disintegrating to give us what we call a daughter nuclide. A daughter because it is produced from the parent together with our radiations and energy. So natural radioactivity have one big or large nuclide at your reactant side and the daughter nuclide with the emissions and energy at the product side. That is how you can identify natural radioactivity. Now let's look at artificial radioactivity. In artificial radioactivity, we are going to have, now this is artificial. What does it mean? It means that there has been an influence on this type of disintegration. Okay, so that means man have a hand in this type of disintegration. So it means that this radiation can only disintegrate or this reaction can only break down when there is what? An external force. So what do? What we do is that because the nuclide for artificial radioactivity is stable, we have to bombard that nuclide with a subatomic particle. So when we talk about bombard, what we mean is that we're going to hit the nuclide with a subatomic particle. Now, when you hit the nuclide with a subatomic particle, it's going to cause a disruption in the nucleus. And when that happens, that nuclide will disintegrate to give you other reaction. What is artificial radioactivity? Artificial radioactivity is the disintegration of a lighter nuclide after it has been bombarded with a subatomic particle to give us other nuclides accompanied by the emission of radiations and energy. So, for example, aluminium. We bombard aluminium with a neutron, we are going to produce sodium, an alpha particle, and then energy. So what can we see? In artificial radioactivity, we are not having one parent nuclide. We have a parent nuclide that has been bombarded with a subatomic particle. So this is our subatomic particle. And that subatomic particle, when it hits this nuclide, it disrupts the nucleus of the nuclide, and therefore it will give you this reaction. So that is how you identify artificial radioactivity. The next thing we want to look at is the differences between nuclear reactions and chemical reactions. Nuclear reactions, chemical reactions. He said nuclear reactions, energy involved here is large. There is larger energy that is being produced, but we have energy here being relatively low. This is not influenced by external factors, okay? So, not influenced or not affected by external factors, while this one is affected by external factors. In their similarities, both nuclear reactions and chemical reactions conserve energy and they also conserve mass or charge. So they both conserve energy and also conserve mass or charge. So that brings us to the end of today's lesson. I hope you enjoyed the lesson. If you did, please make it a point to subscribe, like, and share. Bye-bye.